Hi, I'm David Kais, and I run R for the rest of us. You may think of R as a tool for complex statistical analysis, but it's much more than that. From data visualization to efficient reporting to improving your workflow, R can do it all. On this podcast, I talk with people about how they use R in unique and creative ways. Welcome to the R for the Rest of Us podcast. I'm joined today by Tom Mock. Tom is the customer enablement lead at RStudio. Before that, you did a PhD. I'm actually blanking on what your PhD was in.
Neurobiology.
Neurobiology, is that right?
Mhm.
Okay. And then moved into a customer success role at RStudio. And like I said, now you do the customer enablement lead. So welcome, Tom. Maybe you could start out by just telling folks kind of what your role at RStudio entails, what that means to be a customer enablement lead.
Yeah, absolutely. I'm sitting kind of between some of our customer success reps who work directly with different accounts or customers we have, and then our product and solution engineering team. The reason why it's customer enablement is I'm specifically applying like how can we integrate open source into people who've bought into our professional products. That's kind of the only way everything works is we have all the open source stuff that's amazing. It also works in our professional products. And we have to make sure that things that work swimmingly outside of our professional products work really, really well inside the pro products too. So a lot of the time I spend is like in documentation or advocacy for making sure things work or extending things to make sure that experience.
Cool. Well, in addition to doing all of that, you have a really nice blog where you've written a bunch of different posts on a bunch of topics. And for a while, you were doing a series on tables, which I got really interested in. And we're going to be talking today about one post in particular where you took from some guidelines that John Schwabish, a kind of data viz communication expert, wrote about and showed how to implement them in R. Before we get to that, though, just a bit of background about you. Can you kind of give us a bit of background about when you started using R and why you made that switch?
Yeah, absolutely. I think the first line of R code I wrote probably would have been around 2016. But then started using it much more in earnest in 2017. Ironically, my first experience didn't go well, which I think is true for a lot of learners, whether it's programming or anything, statistics or anything else. And a lot of that was due to how the course was presented to us in terms of intentionally constraining you to think about it as only a statistical tool and not really giving you the guidelines of like, oh yeah, you can do a lot more with this than just, a linear model or an ANOVA. And constraining to that made it really hard to learn as opposed to using it as a general purpose programming tool.
Gotcha. And so that was in grad school, right? And you were at University of North. Wait, no,
University of
not
North
University.
Texas, that was
North Texas. Okay.
second year of grad school. We had the statistics course, and it was taught with R. We didn't use RStudio. We used R Commander as the interface,
Wow.
which is pretty similar to using the R console. So not really scripting, but more of just like interactive programming, which was a rough experience at the start. But teaching myself and kind of learning with the R4DS community, my third year of my PhD was a lot more fun and a lot more kind of rewarding.
So you talked about the R4DS community, that being the R for data science community. Talk about kind of what that was and, what it looked like for you being involved with that and how that contributed to your learning.
Totally. So around that same time of like when I was trying to find a community, it was 2017, third year of grad school. I was really trying to figure out what can I do that is not becoming a professor, trying to get out of the grad school pipeline, still finish the PhD, but get more into data science. So found R, was able to I had some knowledge of it from before, even though it was pretty limited. And then the Hadley Wickham and Garrett Grohlman released the R for Data Science textbook. And around the same time, Jesse Mostopak created kind of a book club based around group reading of that book and kind of interacting. And it really flourished. Like the community grew to be much more than just a book club, but that was kind of the initial creation.
Cool. And you talked about, when you first learned it, it was really just focused on the stats piece of it. To what degree was being involved with R for data science, to what degree did that help kind of open up your perspective in terms of what R was capable of?
Yeah, absolutely. I mean, number one, R4DS teaches the tidyverse, dplyr, ggplot, tidyr, per, all these packages. They'll let you do a lot more than the kind of built-in statistical functions, and really more about doing data analysis, exploratory data analysis, graphing, and working with data. And that was what I was really passionate about, was like, I didn't necessarily want to do just statistics. Like, I wanted to improve my workflow in terms of, I didn't want to do statistics and systat, copy paste the results to Excel, copy paste the results from Excel after I'd done some summaries into PowerPoint, and then also copy paste them into Word. Like, I'm working across 4 or 5 different softwares at this point, and every time you switch, there's that huge switching cost and loss in functionality. So with R4DS and that community, you get exposed to web scraping and iterating across functions and repeating things or creating multiple reports from the same thing, which is all like, it's things that R is really, really good at, but it's not necessarily statistics. It's like general programming or just using functions and functional programming in software along with your data analysis, but all in one pipeline and not having to do that switching cost in and out with softwares.
Cool. And you talked about before you were using Systat, which I'll admit I'm not actually familiar with. So I'm curious if there were things that changed. You talked about, being able to improve your workflow, centralize everything within R. I'm curious if there are other things that change for you moving from Systat to R.
Yeah, I think number one is that Systat is roughly similar to SPSS in terms of you have a GUI or graphic user interface. You say like, I'm running an ANOVA. I click on ANOVA, how many degrees of freedom, type in some things. What are the variables, read it in from a table, and then click execute and it runs all the analysis. I think the biggest thing for me was every time I did that, there was like 10 minutes of prep, 5 to 10 to 15 minutes of like actually getting the commands to run in the correct order, execute. I'm at 25 to 45 minutes of just trying to get my analysis to rerun. And it was essentially the same analysis every few weeks as we were adding on things or doing new projects. When I switched over to R, I just re-executed the script. So I took what was essentially almost an hour of work and was able to basically just rerun, re-execute the code with new data and get, hey, here's the summary of everything. Here's the preliminary statistics. Here's the summary statistics and a graphic. And I could show that to my boss in a few minutes as opposed to an hour. I think that answered the question, but let me know if I went off the rails there.
No, that's great. I mean, I think that type of reproducibility, is a huge thing for moving from a graphical user interface to a scripted process like with R. Cool. So I know you've said that one of the most difficult things for you when you were learning R was actually importing data.
Yeah.
Can you talk about what that looked like and how you eventually figured it out?
Right. Yeah. So, I mean, like, I think it's very key. And again, I'll pull on kind of experience that Jesse Mostopak would talked about was when you first get something, you use your computer for doing Netflix and email and other things. You don't necessarily think, oh yeah, my computer is a way to do programming. So if you have data, like you just double click on the file and it opens up, right? Now I'm opening it. With R or Python or a programming language, like you are much more about like trying to understand what's a file path, which directory am I in? How do I get the file from on disk to in memory? And kind of that's a change in your mental model that's really useful in terms of like what's on disk exists and what's in memory exists, but like you're moving between them. But it's very different than just double click on the file and get going. When I was initially learning R, and the reason I got frustrated is we never talked about that step. Like we just assumed that you were always in the right working directory, which is never the case when you get to your own analysis. Like you have a project or a subfolder that you're working from. And doing things only interactive in the R console meant that you really didn't have statefulness of like your script. It was not that great because you're just executing commands and you don't really get to see like the history or write comments. It's just the interactive portion. So using things like our Markdown or even just R scripts where you can write things out, then execute them, that was a big step for me.
Yeah, I mean, I know I had when I first started learning, and I hadn't done any. I had done some HTML and CSS, but not programming in a similar way to what I do now in R. I didn't understand that. Okay, there was like a CSV file, say, that lived on my hard drive, but it wasn't actually in R as an object until I ran the code read underscore CSV.
Right.
That didn't make any sense. I was like, wait, but there's external data, but it's not in R. And that whole process was very confusing.
Absolutely.
So I think it's interesting to think about how so many of the things, especially as you become more experienced, become second nature for someone starting out or can be incredibly confusing.
I mean, just last week, I know I saw a Twitter thread from someone trying to learn Python for data analysis, and they literally walked through that process like live, being like, "Okay, cool, I'm going to learn Python. I want to, import a data file." It's like, okay, how do I do that? Google import data into this, and it's like, load pandas. It's like, okay, what's pandas? And you go down this rabbit hole of like, not you having to build up mental models on mental models, and if it's presented, but again, like R4DS walks through like how to do all of that stuff, the book. And that was really helpful for me learning of like having it typed out like that step by step.
Yeah, that makes sense. So, and this is actually a question that wasn't on my list.
Yeah.
I'm not trying to throw you any gotcha questions, but I'll probably add a couple in just as we talk. So you talked about finding value moving to R because it could do kind of more general purpose
Right.
programming stuff. So I'm curious, not wanting to start an R versus Python flame war, but just like what value you see, like why do that in R? What do you get out of R? Maybe not in contrast to Python, but like what makes you love R so much? Yeah, I'll leave it at that.
I would say like the startup cost. And, when I was in 2017, I was like, hey, I'm going to learn data science. I installed R and I installed Python. And for Python, the introductory tutorials I found were general software, right? Like make this, do this thing, open a file, transfer it over there, rename it, etc. And I was like, I need to learn data analysis because if I'm going to learn it during PhD school, I have to concurrently learn while I'm doing my actual work. Like I had to use the software for my work. I think a lot of folks actually used R like as a scaffold to learn Python. Like they learn R, the startup cost is lower because you can just install R, install RStudio, install a package, and you don't have to immediately think about what's a virtual environment or what's a project specific library or how many versions of R versus how many versions of Python are on my laptop. Both are super powerful. The customers I work with were very multilingual. Like there's some teams that are full Python, some teams that are full R, or a mix of both. Both are really good at data analysis and there's overlap. I think of like the pandas library for data analysis in Python is actually really similar to a lot of base R syntax with a mix of some of the tidyverse principles. So there's, again, like cross learning. It's like if you can build up a mental model of programming in R or in Python, your switching cost from R to Python or Python to R is much lower than trying to learn them both at the same time. So like learn one, learn it well, use it to be powerful, be happy. And if you want to learn the other one, then you can learn it probably a lot faster the second time around.
Yeah, that makes sense. It's interesting because I've been doing on my website, which is a WordPress website, occasionally have to do some PHP.
Yeah.
And I don't know PHP, but a couple of years ago or a few years ago, I was like, I don't even know what this is. Like, this doesn't make any sense to me. Whereas now, having done some R, I still don't know PHP, but I can look at it and kind of understand what's going on. So I think that makes a lot of sense, is using one language to scaffold your learning of another. So now you having gotten through the struggles of learning, you run Tidy Tuesday. So Tidy Tuesday, for anybody who doesn't know, is a kind of social data project. You release a new data set every week, and then people take the data, do a bit of analysis. I shouldn't say a bit, they do significant analysis, and then often, mostly produce data visualization, sometimes tables, different things. And then you'll see those posted under the Tidy Tuesday hashtag on Twitter. So I'm curious, first of all, how your background informed you starting Tidy Tuesday, and in what ways, if you had had Tidy Tuesday when you were learning, if that would have changed your journey learning R.
Yeah, I mean, if I'm being honest, like Tidy Tuesday was part of my journey in learning R. Like when I was, 2017, 2018, I'm going through R4DS. I'm doing my own statistical analysis and general programming for my PhD. But at a certain point, I was like, hey, I have to talk to people in interviews and interview as a data science, person, as opposed to a neurobiology person, like if I'm stepping out of that persona. And if I talk to them about behavioral analysis in mice, may not land very well. And I'm applying to companies that sold pizza or did marketing. Again, like they don't care about mice. They want to know about like their specific domain or applying the principles. So for me, I was like, I need to build a portfolio. How can I build a portfolio? I can get random data sets from the internet, analyze them, graph them, do machine learning, and that'll be my portfolio. Third step of that, I've got the idea. I've found some data. I was like, oh my gosh, this is an absolute mess to get these data sets out. Or you find tutorials, they're like, oh yeah, just load the data. And I'm like, where's the data? You don't have it listed anywhere. You just have code. I don't know where your data is. So for me, it was very much around like, grab a data set, get some basic summary of that. Like here's a description of the columns and rows and an article that you could kind of build off of it. Like I'm building a new mental model every single week of like, what is this data? I don't know anything about solar power, but let's learn about solar power this week. Or let's learn about bestsellers and popularity of books over time. So my initial go at it was like, I was learning for myself and like bring some people along with me, similar to what Jessie was doing with the R4DS. Like she started as wanting to learn R in a book club with a group. I just wanted to create a scaffold for myself that others could benefit from as well. So 4 years later, it's less so about me kind of learning the core and trying to kind of get back and create scaffolding behind me and not just like tear it up once I'm done, in terms of like not give that scaffolding away.
Yeah, that makes a lot of sense. And for anybody who hasn't looked, being able to go on Twitter, do people post stuff other places? I mean, I just see places.
There's some folks who do LinkedIn, and ultimately I say it's like, even if you never post it, you can just work locally. Like I think there's like 2,000 forks of the repo. So I mean, it's like, I know people are using it even if they're not posting, and that's the purpose. Is just like, use it. If you want to get feedback, then you can ask for feedback or post it and be like, look what I've done. I'm learning with you, or I'd like feedback or whatever.
Yeah. And I mean, for those who do post publicly, for other people then being able to go and see, here's what they produced this week, here's a link to their code, that for people learning is so helpful. I know, students who I work with, I always point them to Tidy Tuesday as a way to just see other people's code. So, all right, let's switch to talking about tables, which is the main topic for today. So, I guess first question, why do you care so much about tables?
Yeah, I mean, for me, I kind of joke in retrospect, it was like a form of like control and pandemic self-care, in terms of I was very much cooped up in my own house. Like we couldn't go anywhere. Texas was not doing a good job of containing the virus or suggesting good practices at the time. So my wife and I stayed in. We do puzzles, we do other things. And I just had more time on my hand because I wasn't doing as much elsewhere. So GT was going, the GT package or Grammar of Tables package was, really ramping up at that point. So I was like, I'll learn about GT and dive into it. And that first jump in terms of like, oh, this is actually very similar to ggplot or other kind of things in the tidyverse where the syntax makes sense. I can be very powerful very quickly, but you still have to learn in terms of there wasn't that much learning material at the point that I saw. So I'm like, well, I can probably do something, kind of share some details about the package and learn a lot along the way. And ultimately, I was just like, I've kind of gone way far in my spectrum of like, I should always use data viz to, should I always use tables to somewhere in the middle now? And
Hmm.
ultimately, like with tables, I think a lot of people will see them out in the wild and they're just miserable. Like in terms of you've got an entire page, it's all black and white. There's no real delineation of lines, and it's just a mess. It's like, well, if you're going to give me that, I'd rather just have the CSV file or whatever. If you're just giving me 10 pages of PDF of a table, I want the raw data.
Sure.
I'm not going to be able to be very powerful with this. But using tables as a summary statistic or an extension of data visualization is exceptionally powerful. You think of like a bar chart, right? A horizontal bar chart is just a table with one column. It's all it is. It's like you have a number, your x-axis is the labels, or sorry, your y-axis is the labels, and your x-axis is how big are the bars. With a table, you could take that bar chart, throw it in there as two columns, like what is the grouping and what is the bar, and then you have 5 or 6 other columns that describe that data or give context. That would be really, really hard to graph together. It's really hard to encode more than 3 or 4 variables at a time versus
Sure.
a table. You're having literal representations of both the visualization and the data itself in small sections. Again, like summary statistics or, 10 to 20 rows is fine if you organize it well.
I think what I like about your treatment of tables is that you kind of put them on the same level as data viz. And because I think you're right, a lot of people just assume, okay, I'm going to spend a bunch of time making some nice graphs, and then I'll just dump the data, the rest of the data, or all of the data in the table. And I think what I liked about the way you just discussed the two is that tables in a way are a form of data viz. I mean, they're a way that you visually present data. And so taking the same level of care in thinking about how you present that can yield really great results, as
Yeah.
some of the tutorials you've written show. Um, what makes R well suited to making tables?
I think first and foremost, R is really good for data analysis, whether that's statistics, machine learning, or just general exploratory data analysis, amongst other things. So you're already doing a lot of your work there. Also, there's really rich publishing tools. If you think of things like R Markdown, you can take your analysis and publish it up into a book or into a website or into a journal article pretty quickly. So there's a benefit to being able to even just have tables in your toolbox. Like it's good to have. As far as why I think R is really well suited is just like we have people who have strong and useful opinions about data visualization. Similar people have extended that into tables. And actually, like you were saying, and I agree with, starting to care about those tables. It's more than just, oh, this is the most basic LaTeX table I can create, to one that's visually appealing, that is useful as a storytelling tool or as a visualization tool. And it kind of can extend what you do with like a scatter plot, and you can have an accompanying summary table that is telling you additional details more than what a different graphic could tell you.
Yeah, that makes a lot of sense. So let's talk about the kind of package
Yeah.
landscape within R. You talked about GT, and we'll in a minute walk through some code that uses GT. But I'm curious if there are other packages that you find useful and you go to when you're making different types of tables.
Yeah, absolutely. Yeah. I'm very much similar to what you do in data visualization. You kind of have to make a hard forked path of what you're intending to do. Do you want a static graphic like a ggplot that is outputting like a PNG, a literal static image, or do you want an interactive graphic that you're almost treating as a small application? is it a story or is an application trying to tell a story? And that's two different kind of use cases. And it's similar in tables. You have static tables that are really good for doing summaries or for small use cases. And then you have interactive tables that wrap things like JavaScript that are actually small scale applications in the form of a table. So for static tables, I really like GT. I think it's very expressive. I was able to kind of hack against it and extend it a lot. And it has some dependencies that I'm happy taking on and I can work with. But there's other packages like Cable Extra that are really, really good at doing like LaTeX. So if you are part of a group trying to publish to PDF and want to do static tables, Cable Extra is really strong. Or for groups that's like, I have to do Word. I want to create static tables, but I have to get them into Word or Excel or something else. The formatable table, Flex table. That's the one. Yeah. Flex table's really good at that.
Yeah.
And I haven't used it as much. But I like what they do with it. They've got good documentation. Just almost all the work I do today is HTML based. So I like GT really well because I can output to an actual image or I can embed the HTML. So as far as static packages, those are the ones I like. When you make that decision to, I want to use like more than 30 lines of data to show, or I want to really like make something where they can interact with it or explore, shifting over to interactive tables with Reactable or the DT package is really nice. You're going to have thousands of lines of data in there. And of course, you could, just package up the file and let people explore it in R or Python or whatever else. But by putting it into an interactive table, you can actually get the user without having to do anything else besides interact with it to answer some of their own questions. They can filter it or sort the data, or there's even like group by summaries that can be done within the table, which is really nice.
Cool.
I think that covers most of the landscape, but I'll just say that just like there's more than one way to do a plot and there's extension packages beyond ggplot in R, there's, I think, like a dozen table making packages in R. So maybe you really like GT and I really like GT, but maybe you have a specific use case in something like GT summary for doing like actual statistical summaries in a table is better for you. So yeah, it's using GT in the back end, but it's a different interface or a different API for you to work with.
Yeah, that makes sense. I'm thinking about kind of what your output format is probably like the most
Totally.
important thing, because I know we have had to use, not had to, I really like the Flex table package a lot. And we use that mostly because a lot of the clients that we work with need, at least at times, need to be able to export to Word when they work in our Markdown. And at this point, I know there's some work to make GT be able to do that, but at this point, Flex table is your only option, pretty much. So yeah, they're like you said, there are a ton of great options. By the way, quick aside, one thing I've thought about with the table course is I've thought about reaching out to I forget Kyle's last name, who does the React table formatter. Queel. Okay. Yeah. I don't know how you pronounce it, but like if we could do something where like you did the static table portion, like talk about GT and like include GT extras, and he talked about React table and his React table formatter, like that could be a cool way to do it.
Yeah, React table formatter is great.
Anyway, just a thought. It's super cool. I'm still work on getting a lot of my clients to be up for doing interactive stuff. They're pretty traditional. Okay, cool. So I'm going to flip over now. Cool. I'm going to put my screen on. So we're going to look through your code in the blog post that you wrote. And the blog post was taking, like I said before, from work done by John Schwabish with kind of guidelines for making effective tables. You go through in your blog post 10 of them. I'm going to go through some of the, I forget, maybe like 5 or 6, some of the ones that seem kind of simplest and kind of most relevant starting out. So what I'll do is I'll just kind of run through some code, ask you some questions, and then we'll take it from there. So I am going to import your data, and we are working, I can just pop it up here, on data on yield of various crops in different countries over time. Cool. So I'm going to run this code chunk here, bring in data. You filter to a few countries, these countries here, and then only potatoes and only for a few years. And so if I even pop up the potato data, you can see that. Now let me go ahead and run. So the first kind of principle is offsetting the headers from the body. So let me actually run what you call a pour example. And so maybe if you want, first of all, and we'll go back to the code, but maybe just talk for a second about what makes this a pour example.
Number one, I think when you're prepping the data, there's some decisions you have to make in terms of, you can imagine that a tidy data set where you have like each variable kind of in its own column and each observation in its own row is great until you need to make a summary table. So you kind of need to break the rules in a good way and make the data set wider. When you were showing the yield data, it already looked like a decent table. Like if you click on that view or the potato data, sorry. So you're going from this long format to a wider format, like that looks like a table. That's a tabular format. It's grouped by country, crop, potatoes is repeated, and you have your different years. So that just making that decision is like your first step of like, how do you want to orient the data to show it off?
And I think, and I'm sorry to interrupt you, but I think that's a really, really important point that a lot of us who work in data sometimes miss, because especially if you work with a tidyverse, you're so used to having your data in that typically longer, tidy format. But understanding that for presentation, that might not be the best, I think is
You get to
really
bend the
key.
rules for your
So I like
presentation
that you
later, for
highlight
sure.
that. Exactly.
No
Okay,
worries. Yeah,
sorry.
so going back to
Go
this table,
go
I
ahead.
think number one, like we talk about these poor and good examples. I basically had to break some of the good things that GT does out of the box. If I just called GT on potato data, it would actually do a pretty decent job of making a basic table. So you could actually highlight potato data GT, line 61 and 62,
Just
and
make
run those. And it will give you a pretty decent basic table. You know, it's got line separators. Go
so
ahead.
well, I was just going to say, so you actually wrote code to make it
Absolutely.
worse,
Yeah.
is
So
what
I
you're
actually
saying.
had to write additional GT code to make these what I call poor examples. And it's not because they're the worst. It's just you're making it harder on telling your story or having the reader get there and basically understand things. So what this bad example is actually doing is removing all of the line separators and giving you essentially numbers on a white canvas. So now if you run line 70, potato table, it'll give you what I call like the bad example. You can probably figure out that there's a column called country and that there's some years from 2013 to 2016, but there's nothing guiding you to say, hey, this is where the table begins and you're looking at values versus variables. And because you're moving from long format to wide, you really have to guide folks to be like, what's the purpose of this table? Am I trying to compare within a country across a year? Am I trying to compare within a year across country? You can basically structure the table in a way that it guides the reader to make those decisions. So it's all white space.
Cool.
If we go to the next portion with the improved example, I've basically like added back in some of the capabilities that are made with GT. You can run this, and now we've made an intentional decision that basically like the most important thing here is letting people know that there's multiple years and that there's a country column, and then you have the data set below it. You could still add, light horizontal lines breaking up between the countries. But the way that I read this table is we're comparing within year across countries, because there's nothing really separating the individual rows. There's just the header being separate from the body of the table. And that's again, it might sound silly
Yeah.
to like make that small of a distinction, but it makes a difference in terms of the end result.
And so looking at your code, it looks like you
Hmm.
changed a couple things because I saw this line here, which is in contrast to this, where you did table lines extend equals none, and so there are no lines between tables. Whereas down here, you set the default, which appears to be to have a line below the header, um, and then at the bottom of the table. And I know you did some other things here. Um, and then you did one other thing, which is in this tab style. You said weight equals bold, and then locations highlights just
Right.
the header. Are there other things you would highlight that you did to make the header kind of distinct from the
Yeah, I
rest of the
mean,
table?
you hit kind of the nail on the head there in terms of the previous example had removed all the lines. If you'd actually just execute like 81 to 88 and stop at op table lines, it will add in gray dividers. So that's kind of the default behavior. And I think that's actually pretty good. Like if that's your baseline, that's what GT does out of the box. That's pretty good. That guides the reader to say, I'm comparing within country across year, right? Because there's a line separating horizontally, but nothing vertically. When the tab options, basically that is removing those lines and hiding them further so that kind of the data to ink ratio is higher and potentially even too high in terms of like if you run the rest of the code, it removes that horizontal line. And I think it then guides the reader to do more of vertical comparison because you have nice columns. You're like, oh, okay, well, it looks like United States has the most crop yields in 2013 and 16 and 14 and 15. Like I'm comparing across country for those years.
Yeah. And so it looks like you did a lot like
Hmm.
here, setting the colors of the border of the grid lines to be white, which obviously makes them not show up on a white background. Cool. All right, let's move on and let's look at the next guideline is about using subtle dividers. So let me, this is just bringing in some data. I can even look at the data, rule to data. Um, Let me go ahead and just run this code and let's talk about um, what is not ideal
Yeah,
about it.
absolutely. Yeah. So again, I'm kind of building up this thing piecemeal by piecemeal. So while the first example is going to be pretty rough, and that's what I see here, like this is similar to a lot of the tables I see in the wild where I've accomplished my goal. My check mark is completed. I have tabular data in a tabular format and it's been saved out. But just like before, we like didn't have any dividers. Now we've gone way too far and added dividers everywhere. Like your eye doesn't know where to go, even though you have dividers. Um, the other thing to me is that I haven't done a good job of highlighting things that are different than the other variables. So you may think, oh, it's 2007 to 2016, when in reality it's 2007 to 2011, then the average of those 5 years, then 12 to 16 and the average of those years. And then at the very bottom, there's an additional row now that's averaging all the columns as they go down. So without separating those out, again, you're making the reader work harder to figure out like what am I supposed to be seeing here? Like what's exciting? What's the story?
Yeah. So let's look at then how you did it. I know I commented out one thing. I'll have to look
Yeah,
back at.
this brings up a good point. So that makes sense. We can leave it off for now. So this first step is
Okay.
essentially what we did before. Add some bold to the column header so you know, oh, these are the headers. It's years all the way across. And then adding a big divider line to say, hey, that country average is the average. Don't think of it like one of the other countries. It's the average of everything. So it needs to be separate visually from the other components. But the part that we left off, basically that tab styling to further enhance the table, if we re-execute that, then now we've highlighted that
That's
there's these average columns across the rows as well. So, not only do you have to think about the headers, but even within the data, you might want to style the backgrounds to extend those, either push them to the background and don't think as much about them, or just really make sure, oh, hey, don't accidentally think this is just another year or lose sight of it in the rest of the data.
That makes sense. And so for that, this code here, so it's all within this
Hmm.
tab style that allows you to set that style. And you're saying you want cell fill to be a light gray, which is obviously what's showing up here. And then you identify the places where that happens. And you want it on the variables called average 0711 and average 1216. Cool. So that's how
And
we get
I
that.
think to point out, like with tab
Can,
style, the reason why it's so powerful is it's not necessarily always, go to cell A1 and click color on it, but do the whole column at once. Like I'm not having to say which rows, just do all the rows in these columns. And you can even extend it further to say
Mhm.
when a condition is matched, do something. So like if the value is greater than
Yeah,
19, highlight it. So it's a way of doing some
highlight
exploratory
it.
data analysis for the reader in terms of like, hey, these values are something for you to pay attention to, or they're higher than they should be, or outside of normal range. So you can do a lot with styling of the table with tab style.
Cool. And to show that even more, you use tab style
Mhm.
here, for example. You are um, doing things like making your
Right.
grid lines vary, right? Like you said, similar to what you did before, having the grid lines be thicker here. Um, so you don't have to set your grid lines different here because
The
I'm
default.
assuming that's using the default grid lines. Okay, so you're only changing it where you need to make it different than that default kind
Exactly.
of
So
light
you're
gray. Is
basically
that the idea?
the default would have gray, like a pretty thick gray at the top, and then very thin light gray lines as horizontal dividers. If you go to line 204, I think. Yeah. So now there's only the light
That
gray
didn't
dividers. But if you look at
I
lines
see. Yeah.
204 through
So
206, you'll notice that we're using, across all the columns, but only within rows where the country is equal to average. So you have this like logical statement saying, look at the data for me, GT, like look at the data behind the scenes,
I
and where this
see.
condition is matched, do this for me. So a lot of
Gotcha.
power there of like using the data to
Cool.
influence what the table looks like itself.
Cool. And actually, you know what? Let me then skip ahead to
Hmm.
highlighting
Hmm.
outliers because you do something similar there. Actually, let me keep an eye on the time. Um, I'm realizing actually it's
Yeah,
almost 10, well, 10 my time. Um,
I can
do you
stay.
have,
I can stay
do you
around for a
need,
while. Yeah.
should I let you go? Okay. If you're okay, I'm realizing I should probably
No
schedule these an
worries.
hour and a half. They- this is the second one I've done and they're both gone over. So
Sounds
if you
good.
do need to go, just let me know. Um, so with highlighting outliers, I'm going to run
Mhm.
this to get your data. Just take a quick look at it. Uh, okay, so we got countries and then several years. And again, we're looking at potatoes. So I'll run this. Um, and then let's look at it without any highlight. So with this, it looks really similar to the tables we saw up above. But just let me actually run it with the highlighting to kind of show like what you the guideline gets at in terms of good presentation of data. So talk about what's going on here, and then we'll talk about how you actually
Totally.
implement it with the
So
code.
here, what we're looking at is we've kind of gone back to the original data without averages, and we're looking at some of the changes over time. Basically, like, did it go down or up in year over year? What we're doing here with color and with GT is saying if any value is less than 0, show it as red. Basically pretending that that's a really big deal, or maybe it's not that big of a deal, but you just want to make sure people realize, hey, this is a negative value. You might want to pay attention to it. And you can make these decisions with whatever logic statement you want. I've just said, within this column, if the value is less than 0, then highlight it for me. You could easily make it the background of the cell instead of the font being colored, or you could add in like an image there and change it to something else. You could do whatever you wanted.
Gotcha. And so you're doing that
Hmm.
here. You're saying style cell text color equals red. And then here you're defining all of the places where that should happen. So basically this row
Hmm.
all the way to the end. So just to give an example then, and let's see if I can do this because I don't actually use GT that
Beautiful.
much, but that did work actually. So that will change it. So it'll now fill the background as opposed to the
And I think that's
text.
the beauty of
Cool.
code is you can like change a component and reuse the bulk of it. With making this decision between like the font color versus the background color, you can really see like this is saying only pay attention to the negative values, right? Like that's basically all your eye is doing.
Yeah.
So you could change the color to be something lighter, like maybe a pink or an alpha, or
Right.
maybe that's intentional. You're like, hey, this is a bigger table. I really want people to just see, like, look at all these values where we're failing or where things are going down.
So if I wanted to change multiple things, would I do something uh like this? So I could do like cell, or no, what was it? Cell text color
Hmm.
equals white. Does that work? Ah, okay, perfect.
Yeah.
Cool. Yeah, that is really easy to switch from
Nice
one
work.
thing to the next. I will say I didn't actually know how to
That's
do that because I
awesome.
don't use
That's
GT
insane.
that
Like
much.
it's
That
an
was not me
intuitive
pretending.
interface, I hope.
Yeah. Um, all right, so let's talk now about alignment. So John Schwabish talks about right aligning numbers and values in the header row. So the data that you use here is really simple, just 1 year looking at various crops in the US. And then you actually make a table that shows various options with the numbers left aligned, the numbers center aligned, and the numbers right aligned. So talk about, first of all, why you think you and John Schwabish agree that right aligning numbers
Absolutely.
is
Yeah.
better.
So ultimately, while I think that tables are a useful visualization tool at some level, ultimately the basic purpose of a table is to show exact values. A graphic, you can estimate exact values, like be like, okay, this XY coordinate is approximately this. But with a table, you're literally looking at exact numbers and you're trying to compare them or look at the numbers between rows, between columns with numbers and the way that, at least in an English speaking kind of community or good large portions of America, you're looking at numbers from left to right and classically are right aligned. The reason they're right aligned is you can compare at the same decimal place. So if you look at the right align or the furthest right column and hover over that, you can see that the decimals are perfectly in a straight line. So whether the number is big, 48.64, or small, like 3.49, they still align with each decimal and each number is in their own little column within the column. And importantly, some numbers are wider, like a 4 is actually much wider than a 1. So this is using a kind of equally spaced font so that whether it's a large number, a small number, a thin number, or a wide number, they all align within the right column. So right alignment works here. If we break this alignment and go against the rules that are baked into GT, we can look at center alignment and you can see that it's actually starting to be kind of hard to see where things align. Your ones start getting really thin and things are a bit muddier. You're like, well, is 11.74 bigger than 811? Oh, that's 8.11. You're over the place. And it's even worse if you go to left align because now all the units are aligned, but your first digit is nonsense. 2 is not bigger than 48, but the number 2.06, the 2 there is in the same column as the 4 and 48. So now your comparison between values is very difficult.
And are you saying, so I know you actually have a
Mhm.
section on choosing appropriate fonts for tables, which we're not actually going to talk about today. But are you saying with right aligning, does it space the numbers differently if you do right align versus center align, or what's going on there
Right.
that makes them so
Yeah, so
nicely aligned
there's
when they're right
two
aligned?
types. Well, there's many, many different types of fonts, but I'll talk about two or three. You have a classical font where you're just like, is it serif or sans serif? Like, does it have decoration or no decoration?
Hmm.
Beyond that, there's things called monospaced fonts. Monospace means every character in that dictionary, so A through Z, 0 through 9, as well as decimal places and other things like that, are all the same width. So whether it's a period, a 1, or a 0, they all take up equal width within that row. Um, these are not true monospaced fonts because the decimal places are thin, but they are equally distant for characters and numbers. If you wanted to, you could do at the end of this table, opt table font. And I think we can do, let's see, font equals, I think Courier or Courier New is baked into most operating systems. Let's see if we can find that one. Yeah. So now this is a
There
monospaced
we go.
font. And while the units are all the same, in terms of like with that font we were looking at before, you might see that the decimal place actually takes up more space on the screen here than it did before. That's because not only do the numbers and characters all one unit across, but decimal places, commas, dollar signs, whatever, those are all also one unit across. GT's default font is I'm forgetting the actual term, it's not monospaced, but all of the characters and numbers are equally distant.
Great. So it works. It works
Yes.
well, especially when you right align it to be able to compare. Cool. So in contrast to right aligning for numbers, you talk about John Schwabish's suggestion to left align text and headers. So in other words, text within the body of a table as well as any header rows. So same thing, maybe just if you can talk briefly about why that's a
Yeah.
better
And some of
way to
this is
go.
specific to locale. Like you could imagine in countries or societies where you read right to left, you might actually do the inverse. But for this English format that we have, based out of like my experience in home country here in the United States, we're reading left to right. The reason why we're doing that for basically character strings or factors, as we see here, is that you might have varying lengths. Like most numbers are around the same number of precision, like the same number of decimal places, and you can decimal align, and that's useful. For text, reading it left to right, if we start from the leftmost column, which is actually the right alignment, you can see that your eye is actually having to bounce from the left to farther right to way left to way right when you're reading down. So from British to Cayman, not too bad. From Democratic Republic of Congo to Luxembourg, you're moving very far to the right and going back and forth. So you're basically like your starting point is varying between every single row. And when you do that on like a larger table, it makes it worse. For center alignment, I actually find this even harder to read personally because you don't have a similar ending or start point. You're starting in the middle of a word, and nobody starts from the middle of a word. You might start from the right, you might start from the left. That's appropriate. But starting from the middle, you're bouncing, you're not even making real words. You're like starting at the M in Luxembourg. Like you want to either do Luxembourg or in different languages reading from the other side. For the left alignment, now your words are all starting from the same place. They might end in different places, but when you're looking down, you have a comparison, the starting letter or the length of the word. But regardless, British, Cayman, Democratic, Luxembourg, United, Germany, New, Costa, Peru. Like I can go through that very quickly, and my eyes are only moving vertically. I'm not having to bounce to start to read through all those different lines.
Cool. That
And
makes a ton of sense. And so
I was
just
going to
to look
say,
at the
like, when you're looking
sorry,
at
go
this
ahead.
code, I am again breaking the rules of GT. GT will always default to having text as left
Right.
aligned, numbers as right aligned, and uses good default fonts. But you can bend or break these rules in certain situations. So here I can say, like, take this column and align it left or align it to the center or align it to the right. And there are specific small scenarios where that's appropriate. Um, if you could imagine,
Mhm.
like year, it's always 2000, 2001, 2015, 2022. At least for a long time, it's always going to be 4 units, right? So whether you right align it, left align it, or center alignment, everything's always going to be perfectly aligned because all of the strings are the same length. So that's a way where center alignment might actually give you better spacing of the columns and everything still stays aligned.
That makes sense. So if you do want to break the rules, like you said, GT does a really nice job
Yes.
of giving you kind of good defaults. But if you do want to break the rules, it
Hmm.
looks like it's these lines here that show how you can manually set alignment with the calls align function, and you give it whatever alignment you
Right.
want, tell it what column or columns, and it'll do it for you. Cool. Let me just see a couple.
Cool.
Yeah, so we'll just do two more, and then I'll
Sounds
ask you about GT extras. So, um, all right. The next principle is thinking about the appropriate level of precision. Let me run your code. And you talk about the this chart, or sorry, this table here. Um, and you talk about, how you would identify whether you're showing too many decimal places, too few, or as you put it, about right. First of all, how do you make that decision? And how do you know what
Yeah, so
is
I would say part of
about
this is your
right?
domain expertise, or if we're falling back to scientific principles, the accuracy of your tool. I can have a tool that weighs things in pounds, and that's its maximum accuracy, not ounces, not grams, but pounds. If I take 2 humans, one who weighs 115 and someone who weighs 130, and I average them together, I might get something where it's like, oh, it's 121.1678425 pounds or whatever. Like the average of those two numbers adds all this accuracy that your tool actually is not appropriate for. It's not giving you that level of precision. So while you can make it round and be more aggressively rounding or less aggressively rounding, part of that is your decision. There's the visual component where, writing 17.666, like, is that 6 at the end adding much to what the reader is getting out of it? Maybe if that's the case, you need to change your units and it should be like 1760.66. My default behavior is I should have like 1 or 2 units of decimals, unless my tool or domain expertise says more or less are appropriate. If I aggressively round, like the too few decimals in the middle, I'm actually losing quite a bit of accuracy in terms of I'm rounding up and I'm losing, zero point 0.3 or zero point 0.5 or 0.75 or whatever of the units that are, valid. Maybe I'm supposed to have that much accuracy. But generally, 1 or 2 decimal places gives you a nice balance of not aggressively over rounding, but not just printing out too much stuff that's confusing the reader. It's a lot harder to read 17.6866 than 17.7. And the difference is minuscule.
Yeah. Yeah, so I work with a lot of social sciencey data, and I don't remember who I heard saying this, but the best advice I've ever heard is because the tables that I tend to work on are for a lot for like policymakers or stakeholders and nonprofits, to measure kind of how effective their work is. It's would an additional decimal place change some decision that they would make in terms of how they implement the policy or that type of thing. And if so, include it. If not, then you're okay to round to, I kind of default to the same thing, like 1 decimal place. Um, So another good way I found at least to think about it. So in terms of the code, um, so I note that I'm guessing these are the two things you've done here. Um, so explain why you only had to do that twice. Like, how do we get
Yeah. So
this
what I will
one?
say is part of the beauty of GT is not just that it's changing the visual component of the table, but it's actually working with the data. And R itself has really good tooling for working with data and presenting numbers and other things. So the default behavior is kind of like, about right. Like it's going to give you 1 unit of accuracy for a column. You can format that number and say like within this entire column, round them all down to 1 decimal place or extend them out to 3 decimal places or whatever you want. And there's even functions for like converting dollars. You could imagine like if this were $17.7, it makes 0 sense to have $17.6866. Like that just is kind of silly. But 17.70 or $17.70 is an appropriate level of precision for $sign. The other one, and to your point of like policymakers, should you print out something that says, there were $152,346.57 spent on this, or should it be 145K? Like you can actually use GT to change this very long string with probably too much precision to we spend about $250,000, like 0.25 M, and that's 0.25 million, or 2.5 million, as opposed to 2,5000,000.
Yeah.
Mhm.
And just so I understand the code, like if I comment those out and rerun this, um, it'll create all of these columns because the way, let me even run up to here. This is the data. So GT will just display the data that's given to it. So in other words, the data that we
Right.
showed before has all of these decimal places. GT is not going to change that. But when you add these FMT number, and I know they're, FMT dollar and other options as well, that's how you can change the presentation of
Yeah.
those
Yeah. So
decimal
it's going to give
places.
you the defaults, and maybe
So
the
that's how
defaults
we did that.
are too permissive in terms of, again, I don't want 4 units of precision here. If you have a tool where that's appropriate, yes.
Right.
But you can control all sorts of components through the format functions. And there's more, again, there's more than just decimal places. You can scale them down. So divide them by 1,000 or divide them by 1,000,000 with format number. You can apply it only to specific rows. You can have it ignore NAs or missing values. Like there's a lot of times where you're going to be formatting the data beyond just changing the decimal place.
Cool. All right, let's go to the last one. Whoops. I did not publish. So the last principle we'll discuss is grouping similar data. Let me run this code and look at the data that we have. So we've got country, crop, and then a couple years data and percent change. So your bad example is this. Let me go ahead and run that. Just briefly talk about what do you think is bad
So if you
about
hover
this
over the
example?
country and crop columns, this is where I think that it's problematic. Basically, you have repeats of country and repeats of crops, but nothing is grouped. So you can't really. The only comparison that's really appropriate right now is what's the max, and do other countries decrease from that? That's basically how it's been sorted. Is United States has the largest crop yield potatoes in both years. But then when you try and go down, you're like, well, United States soybeans are really low, but what about compared to the rest of the world? And you're like, I think it's higher, but what if there's soybeans at the top? And you're bouncing around within the table too much. So to make this a more purposeful table, I would probably group those variables and essentially say, well, I'm going to make a decision, and the purpose is to group it by country. So within a country, what are their crop yields? And that will still make it easier to compare within a country as well as between countries because they'll be split out from each other. So run that and we'll take a look at it.
So just all you did from a code perspective to group it is you added the group name call. And let me even run, like, just if I run it
Yeah.
without any
And again, the
formatting,
default is good.
what
Like
we
I
get
would
is
accept that
that. So it's,
default and be like, yeah, I'm pretty okay with that. The other
yeah,
theming I've done is
yep.
mostly just even probably taking away too much just to highlight that there's groups. But that default is good and it's grouped the data into each of the different countries.
Right. So we can see if I rerun it with all of your theming, it does some bolding, changes some of the divider lines, etc. So that's one way you can, in a line of code, add that grouping. Another thing you talked about was
Mhm.
removing duplicate data. So just to go back and kind of remember, this is what our data or our table looked like before. And then if I scroll down here and run this, let's look at how you did this. So talk about what you
Yeah.
did and how you
So
removed
I really like how
duplicates here.
GT has like a baked in way of doing group data. Other people might be used to this format where you essentially delete several rows and that indicates that there's a group. So basically, because there's missing data below China until you hit India, that means that all those other rows are China. And that's just a decision. It's not necessarily bad or good or the right or the wrong choice. That's just how you want the table to look or how your readers expect the table to look. And if you show them the other one, they're like, well, this isn't what it was like last week. And they might get annoyed and you got to work up to it. So what we've
Sure.
done here is just said, if the row is not the first one within each group, then change it to a blank. So it's just basically not printing anything in those columns. And I think that's line 530 through 536. The text transform function is, I don't know what else to say besides it's bonkers in terms of the stuff you can do with it. I mean, that lets you say, like, with the actual value in that cell, do anything in R. There is no limitation, anything you want to do in R. So that's how, like, with other packages, you can add graphics or symbols or JavaScript or HTML or raw LaTeX. You can do all sorts of crazy things. For this basic example, we're saying take the text that's there and transform it into something else. So for the column where it's country, basically the country column, and if the row of crop is not equal to potatoes, then put in a blank there, essentially. And
And
exactly,
that's because
potatoes is the
potatoes
first
is
row in
first.
every group. So obviously, if you had a different table, you couldn't use that exact code, but just some logic statement that says the first row by group do this. And it could be a dash or whatever else you want. It could be fill it with background color. But with text transform, you can literally do almost anything you can think of. It's a very powerful function.
Cool. And the reason I like these two is they do, these two examples
Yep.
show kind of the same thing, but just different approaches on doing that kind of grouping in a non-default way. Because I think, again, like those of us who work with data all day, this data looks great from like a tidy data perspective, like perfect. I can work with this. But from a presentation perspective, this or this is going to be much easier for folks
Exactly. And
to
some of
make
the
sense
decisions
of.
you're making here is, do I want a table that's slightly longer or a table that's slightly wider? What is the space you're working in? So what is the format you're writing out to? How much width and height do you want to fit the table in? Can it fit all in one page if you orient it slightly differently? Those are the design decisions
Mhm.
where pivoting from longer data to slightly wider or even very wide data can be a good decision.
Makes a ton of sense. Cool. That was
Thank
great.
you.
You're a very good teacher. Have you done
I've done a
like
lot of
formal
teaching on
teaching?
GT. So I've got a lot of workshops I do on GT for sure.
Okay. Yeah, yeah. Um, cool. Well, last question I'll ask is, whoops, you've developed the GT Extras package. Um, do you want to talk briefly about
Totally.
some things that does? And like, I'm curious if there's are there things that we went over that the GT Extras package makes easier, or does it just add on additional things to
Yeah,
what you're able
I would
to do
say
with
it's a
GT
mix of both
tables?
in terms of making things easier or extending it. At a technical level, GT Extras is wrappers around GT code. It's all possible by hand with GT. That's the only way it works is I'm actually using GT code. But by
Mhm.
wrapping up what essentially would be like 30 or 40 lines of boilerplate that are essentially the same every single time, I can write a function that does that. So if you go to GT Extras documentation, there's what I would probably say is go to the reference for themes. That'll be a good one to example. So open up the 538 and the Guardian. Yeah. So these are what I would call like typographic or data journalism inspired themes. You can imagine that the default theme for GT with the gray and thin dividers and specific fonts is fine. And I actually really like it. But there's a reason that 538 or the New York Times or the Guardian or whoever else themes their tables in a certain way because it's their brand or they think that it's a really good way of presenting the data and they like how it looks. So these themes are many, many lines of code. They changed the fonts, they changed the dividers, they changed the bold and italicize and remove and add specific components. And I don't want to type out 40 lines of code for the theme every time. I want to just call, uh, GT theme New York Times, and it does all those changes at one point. So those out of the box themes, I think, are one of the most compelling examples. Because I really like how they put those together. And if you actually look at the code, it's GT code behind the scenes. But it's, you know, it's just a lot of repeats and I don't want to type it out by hand. So,
So this is
mhm.
the New York Times theme, and so
Yeah.
basically this
So
this
about
is the code, right?
34 lines of
That would
code. And again, like that
right.
code never changes, right? It's always the same. So that's a good time to wrap it into a function because then I can just call that code verbatim. And it literally takes an existing GT object, uses GT tab options, GT tab style, and it repeats to change all these different components with specific fonts and typographic or stylistic changes. The other compelling thing for me, if you
Cool.
go back to the documentation articles, is again this merging or this
That
idea of making tables and visualizations work together. So you might think of like spark lines, and that's really a lot of time people are like, "Oh yeah, I've got a table. I'm used to spark lines and whatever like that. I can see what is the trend over time. I don't really care about the exact values. I just want the graphic showing what things have changed." So again, with one line of GT code or GT extras, GT spark line, it'll convert all of those values into a spark line by row, by group within the context of GT. Or if you wanted to plot like a distribution, you can actually scroll
cool.
down, you can do density plots or histograms to actually show the distribution of everything. And again, like this is a good summary table. I don't need to show a graphic that has 4 encodings within a very small space. I can show you the
Right.
exact groups, the mean, the standard deviation, and a basic representation of the distribution, all within a compact table.
Cool. Yeah, that's great. I see you got inline bar charts, percent charts. I don't even know what a win. Oh, I've seen this as win-loss charts.
So yeah, those were
Yeah,
the most
that's great.
the original creation of the package was about, I wanted to apply my own themes consistently rather than having to copy paste code around and around to do the formatting. And I wanted to embed more graphics into the tables and make it robust against unexpected user input. And that's what a function is for. Sure, I could have a function that only I can use,
Cool.
and only I know how to use it properly. But with a package and with GT Extras, it protects against unexpected inputs. So if you try to do it wrong, it won't let you. It'll say like, hey, this is what you're supposed to be doing. Change the data to this format, or it'll only let you do it within the context of a GT table.
Great. Well, thanks, Tom, so much for chatting today. I really appreciate it. And it's great to learn about all the different things that you can
Thanks
do
for
with
having me.
tables. So thanks again. That's it for today's episode. I hope you learned something new about how you can use R. Do you know anyone else who might be interested in this episode? Please share it with them. If you're interested in learning R, check out R for the Rest of Us. We've got courses to help you no matter whether you're just starting out with R or you've got years of experience. Do you work for an organization that needs help communicating effectively with data? Check out our consulting services at rfortherestofus.com/consulting. We work with clients to make high-quality data visualization, beautiful reports made entirely with R, interactive maps, and much, much more. And before we go, one last request. Do you know anyone who's using R in a unique and creative way? We're always looking for new guests for the R for the Rest of Us podcast. If you know someone who would be a good guest, please email me at david@rfortherestofus.com. Thanks for listening, and we'll see you next time.